So previously we learned some basics on C#, some basics function, operations with the game objects, so worked on UI, and now let's try to do some practical things and let's create some program, some game. We'll create a racing game, for example. So for that procedure I'll create a new GitHub repository, create new repository, give it some name, Unity car game, add readme file, gitignore file, select Unity, create repository. Next, we'll go to the fork, and make a clone of this repository. File, clone, clone. And in this folder create a new Unity project. Go to the Unity Hub, new, select the location of the GitHub repository, Unity car game, select folder, and give it a name. Great. So now we need to wait for some time once the project will be created. And how we'll create our game, we'll use some assets. For example, Unity has asset store, and here you can search for some assets which were created by other users or for some Unity team, and here you can purchase them, or you can also sell yours if you created some assets. For example, we can search for racing track. Here we can select price. For example, we can only work on free assets. Select this toggle and only free assets will be provided to us. So for example, we can select this mountain race track, and first of all you need to register here. You need to register and then you will be able to add these assets to the Unity. So you click add to my assets, accept, and then you will be able to open it inside the Unity. But currently our project is under creation, so we need to wait for some time. And for example, we can also search for car model of the vehicle, car, and select the one you like. Also some payable models, but also you can select any free model and select a free. For example, there are some good quality models and there are some low quality models. For example, the size of this car model is 30 megabytes, and for example this one is low poly model, so its size is 2.5 megabytes. For example, we will work with that low poly model, so I will select this one. So our scene was created. First of all, I make some adjustments here on layout and make some changes in the fork. So we previously created the gitignore file, but it's not located on the right place because we have a bunch of files. we won't be able to stage all of these files, so we need to locate the gitignore file in the right place. So gd git car game and move this gitignore file to the Unity project, and this number of files will be reduced. So then we select all of them, stage, write commit subject. Without that we won't be able to commit these files. Write something Unity project. Let's create it. And push them. And I will be able to see them here. So now we have Unity project here and commit subject. Our assets folder. Now let's import some packages to the Unity, the car and this track. So I need to click add to my assets, accept, open in Unity, open Unity editor. Here I need to click download, wait for some time when it will be downloaded, and import it. Click import button, and now it was imported. Here some folders. And seems like this tracks some errors. So first of all, need to fix them somehow. Prefab, index 0, missing. Okay, strange. Okay, here we go. And some problems. Yeah. Okay, it's good. Next, our car model. So first of all, you need to also add it to your assets. You already made it, so I need to click open in Unity. Import. So I will have car. Here prefabs, and here some prefabs of the car. So let's place our car on a scene as well. Drag and drop it to the hierarchy. And currently it's out of the track, so we need to adjust track somehow. For example, let's make it later. Currently I hide it, and I will unpack this car prefab. Prefab unpack completely. And in order to manipulate with that car, I will add a currently simple plane. So car will be located on a plane. I will read its position and increase its size. And probably give it some color. So what we can do with that car, for example, we wanna camera. Well, so how to make some movements of the car? So we need to create some script, create folder scripts, create script car control. And open it. First of all, we need to add some physics to our car to make it move. So how can we make that? For example, this is our car object. It has body, has wheels, so just that simple model, and currently without any physics, because we are currently not seeing any rigid body component attached to it. For example, here I'll create another element, sphere, for example. Currently our sphere has mesh render. We don't need it, so I will disable it. So I will have just this collider, green color collider. So by this collider we can, for example, collide with other objects, with other cars on our scene. So it's better to make this sphere with collider look like the car model, the body model. So it's better to have this type of collider, but if you just simply wanna make some movements of the car, so this sphere will be enough. And as we can see here, currently our sphere is located not in the right place. It's located more down, and we wanna touch it, the ground. So how to make that? We need to move it a bit halfway far. So it will have 0.5 value. It's exactly what we need. So how we can move it? For example, move our car up, and then we can move these things down. So now our car is touching the floor and our sphere is touching the floor. Now let's add some physics to our sphere, add rigid body component to it. and move to the program, to the script car control. So we will attach the script to our car, not here, and let's make some movements of the car. So our car will have some speed, so write public float max speed. You can provide some default values to it. And next we'll work with the rigid body component with our sphere. So I'll create public rigid body RB. First of all, how to move this rigid body component. In order to move it, we need to first of all write this rigid body component and add some force to it. Add force. And where we wanna move it. For example, we wanna move our sphere forward. Transform dot forward and define some speed. For example, 100. So now if I start the program, this sphere will go forward. This sphere. Yeah, first of all I need to attach rigid body component to the public variable sphere. I attach it. And then again sphere. Start it, and sphere is moving forward with some weird rotations. For example, we can place it not to the start but to the update, and try one more time, because in the start it only was instantiated only once, but now in the start it will be more clear. So now I started the program and sphere moves forward. And how to make our car movements, what we need to do is to follow this position of the rigid body component of the sphere. So we can simply write here transform position, which will provide us coordinates of the object to which the script is attached to, and we simply assign to this position RB position. So now what will happen, if I start the program, our car will follow the sphere. So it flies away really fast. In order to see how car moves, we can also attach our camera here. So car will also follow, camera will also follow the car. So try again. Now we can see that it goes really fast. And one thing we need to notice here, is that example, this is our car, and where is the sphere component? Again, I will start again. Pause the game, and again, our car and sphere object, and they are not in the right place. So why that happened? So there's some distance between them, because what this script is doing, it's following our sphere. So our car tries to follow our sphere. So if we move sphere, the car moves, but our sphere is attached to the car. So when we move our car, the sphere moves as well. So if car moves, sphere also moves. Then we move sphere, next car moves and sphere moves. So they are not longer in the same place. And because of that behavior, the movements of the car is really fast. So what we need to do here is to remove this sphere from the child, from the car game object, and start again. So now the behavior is better. So now it's moving not so fast, and here we have sphere and car object at the same place. But for example, we don't really want to remove it manually. So for example, we have many cars, and if this sphere will be out, we have many cars, many spheres, it's not very good. So we can do this operation through the script. So what we can make through the script, once our game started, we remove this sphere. So how to make that? Currently this sphere is parent towards this game object, so we need to go to the start, and here we write rb dot transform dot parent equal to null. So once we start our program, that rb component won't have any parent, it will be separate from everything. So again, I started. So we have the good behavior of the car, and our sphere is no longer part of this game object. So next, what we can do is to add some control, some accelerations to our car model by our keyboard buttons. For example, player settings, input manager, here we have access predefined by Unity, and we are looking for vertical axis. For example, we want to move our car forward and backward by these mouse buttons, down and up. Positive button, which is up, will move our car forward, and negative button down will move our car backward. And we also can use S, W, which are the commonly used WASD, commonly used buttons for games, but you can use arrows or these buttons, SW, AD. So what we need to do is to copy this name in order to get access to these buttons. So I copy it. Go to the script. And add some control here. First of all, if we do not click any button, we need to provide speed of our vehicle equal to 0. So I'll add one more variable, float speed input. And here in the beginning I will provide it value equal to 0. So which means that if we do not click any button, our car do not move. Then if I will click forward button or backward button, I wanna move my car. So if input get axis, name of the axis what I copied before, vertical, and bigger than 0 means that I will move my car forward. This is the up arrow button or W button on the keyboard. And here I provide some acceleration. Speed input equal to input. Again I write input get axis, again vertical, and multiply them by forward acceleration. I will create more variables, float, and also make it public in order to be able to change it from the scene. Public float forward acceleration, give some value, default value, and also reverse acceleration, and give some value as well. Here I will multiply it by forward acceleration. So what did I write here is that I'm multiplying this value. It's changing from 0 to 1 when I click in the keyboard button. So it will change gradually. Not at once, but gradually from 0 to 1. So here, first of all, it's changing by this value, and then I multiply it by forward acceleration. So that it means that speed input modifies gradually. And if I remove this statement, it will be the constant speed. It's not really realistic, so we add this here from 0 to 1. This is the forward direction. So for example, now I can replace it with the speed input and test it. So I click my forward button and the car moves forward. And let's make the same for backward direction. And currently I release the button, but car is still moving by inertia, so we'll fix it a bit later. Currently let's make the movement backward. Okay, we detected the positive direction, and now we need to detect negative direction, another button, which is smaller than 0. And here we multiply by the reverse acceleration. So we save it and test it. So now I can move forward and I can move backwards as well. Forward and backward, and I release my button and the car goes by inertia really far. So what can we do here? For example, here we can control forward acceleration from this scene. And that's how fast our car will move, but it also will stop more longer. So in order to control the movements, stop movements, what we need to do is to again go to our sphere and make some adjustments. For example, first of all make our car more heavy. Rotate here, mass, and these parameters will be in charge for how fast it will be stopped. Now let's test one more time. So currently I'm clicking my mouse button, but now it's moving really slow. So now I need to increase these values in order to be able to move my car, and maybe increase even more. So now our car moves at normal speed and it stops faster, and we can play with the parameters. We can increase them, for example 5, and our car will stop more faster. So you can choose your individual option. 5, 4. For example, I will leave 5 and 4. But also we need to increase the speed here. We can write here with these big numbers, but it's not really good looking, so we can simply make the same things inside the script. So here we'll have small number, which is more easy to modify, and inside the script we will simply add here the statement multiply by 1000 instead of operating with that big numbers inside our scene. So now I will play one more time. So now it's move at normal speed and it stops at normal speed. But currently we can move only forward and backward. We cannot do any rotation. So let's now deal with rotation. For rotation we will use another axis, which is the horizontal axis. So here we have left arrow button, right arrow button, or A button or D button. I'll copy it and we'll create new variables first. Float, turn, strength. And it's how the angle, how far we want to rotate our wheels. And we need to define the rotation turning speed as well, as we had here. Speed input, here we'll have a turn input. Float, turn input. So now inside the update we need to first of all get access to the horizontal axes. Right, turn input equal to input dot get axis. Now I paste the copied name horizontal, and now when we wanna rotate our vehicle, firstly we will check whether we make a movements or not. So get axis, here write vertical, and verify whether we are moving or not. So what I'm making here, we also only need to make rotation of our car when we are moving. We don't want to rotate it when it's stopped, so only when we click in these buttons the vertical axis is in charge for it. So this sign, exclamation mark, and equality sign, which means that it's not equal to 0, that means that it's either bigger than 0 or smaller than 0, which means that we are moving. So if we are moving, we are doing something. So we need to now deal with the rotation. Transform rotation equal to quaternion, and next we need to define the rotation itself. If I simply write quaternion, I won't be able to work with the 3 coordinates, which are x, y, and z. So in order to be able to work with them with the vector coordinates, I need to add here dot Euler. So now you'll be able to work with the 3 coordinates x, y, and z. Transform dot rotation And as I previously defined earlier, here I also need to write earlier. And we want to rotate our car only along y-axis. Here's the y-axis. So we will rotate only around this y-axis, our car. So I'll only modify this axis, the x-axis without changes. Plus new vector. X-axis without changes, so here 0. Then our input, turn input, which we gradually receive from here. Turn input we multiply it by turn strength. And next is our z-axis without changes. Currently I will leave it this way. And let's see what will happen. I will start the game. So when I stop, when I move in and rotate, something really weird happened to our model. So how we can fix that is to try to multiply this value by time dot delta time. Now I save it again, start the program. So now I'm moving and rotating my car. And when we stop, it's not rotating, only if I move the car, it's rotating. But the another thing, if I will move backward, the rotation is not correct, because I need to click, for example, right arrow, and it should go to the right, but it's going left. So how we can fix that is to detect sign by which direction we are moving our vehicle. Here we have map sign, and here is the speed input. We are detecting whether we are moving forward or backward. So I save it and go here again. Now if I move forward, backward, and rotate, I have an appropriate rotation and movements. Next, what else we can do on the rotation? For example, if I on a low speed, our car is rotating not really realistic, but on a high speed it's rotating pretty good. But on a low speed it's rotating to a big direction. So what we can do here is to add another condition to this statement. We can multiply it by the following statement: rb dot velocity dot magnitude. So that's how we detect the speed of the car, of the sphere, and then we derive it by max speed. So when we are on max speed, when speed is higher, the rotations will be bigger, but when speed is lower, we won't have that big rotation. So now, if our vehicle moves not really fast, we are rotating a bit slow, and when speed is high, our vehicle rotates as a bigger rotation. Next, let's set up the maximum speed of our vehicle. So our speed is provided by this function rb velocity dot magnitude. So firstly we can print this value and see how our speed is currently looks like. For example, print and see what we'll get in the console. Currently it's 0, and it's gradually speed up till some these values, and then it's gradually stop. And here we can see the history of its movements: 0 and gradually to the maximum speed. So for example, we wanna limit it somehow. What we need to write here is some statement if statement rb dot velocity dot magnitude is bigger than max speed, we limit the speed. So how can we limit it? rb dot velocity dot magnitude. For example, if we write max speed, we can try it this way, because as you can see, we previously learned properties. The magnitude only has get parameter. We can only read values from here. So in here you can see read only. So we cannot write anything here. So what else we can do here? How can we fix it? For example, we can remove it and only work on velocity and make some limitations here. So how to make them? RB dot velocity dot normalized and our max speed. So what this function will do, normalized, for example, currently we have these values in a history from 0 to some 55, something like that. For example, currently we have from 0 to 55. And what normalization will do, it will normalize them from, it will reassign them from 0 to 1. So previously we had from 0 to 55 or something near that. It can be any number, for example 65 or 55, but if we write normalized, we'll get from 0 to 1. And what we are doing next, we multiply them by our maximum speed. So if we multiply them by our maximum speed, it will be from 0 to 30. So that's how we can limit our maximum speed. Let's try to test it. Currently it's 0, and we currently some different numbers also appeared, something bigger than 30. That's probably because I need to move it all after the end of here and print everything here. Let's try one more time. So now we can only go till the 30, till the value 30, forward and backward. So what we can do next is to add some realistic to our movements. For example, currently if I do some rotation, our wheels do not rotate it. So let's make the rotation of our wheels. Here I will add new public variables to which I will attach our left front wheel and front right wheel. Public transform left front wheel and also right front wheel. Right front wheel. And also define how far I can turn them. Public float max wheel turn equal to 25. So firstly I will attach my objects to this front and to front left and right wheel. Here I have game object wheels, meshes, front left wheel, front right wheel. So I'll attach them to corresponding transform variables. Front left wheel and front right wheel. And here I will make the rotations of them. For example, left front wheel dot local rotation scale local rotation equal to quaternion. Also here we will work with the three coordinates, so I'll write order left front wheel local rotation. You also need to write order angles dot x, and we need to define around which axis we wanna rotate our wheels. Also around y axis. Example, here it will be more clear if I rotate it around y axis. It's exactly what I need to get. So here I do not touch x axis. I leave the left front wheel like a local rotation or angles x, but I modify the y axis. Turn input multiply max wheel turn and set one without any changes. Keep that. So turn input. What is the turn input? It's the input from our keyboard button, left arrow or right arrow, and we multiply it by hits from 0 to 1, and we multiply it by max wheel turn, how far we want to rotate it. So let's save it and try to test. Also previously, let's make the same for the right wheel. Wheel right, and here right. Let's check it. So now I can rotate my wheels. Right one, so let's check the left one and also the left one, and can do more realistic movements. With the wheels rotation. So we currently can't see any changes here. For example, if we move our camera somewhere, we'll see that our wheels rotated. Currently we can only see it on a scene, but let's make something different. Let's add an additional camera. We'll use another camera, not this main camera. So I'll remove it, and let's try to add another camera from the package manager. I'll open package manager. Here I'll search for Unity registry. Here's some Unity packages, and here I'll search for package which is called Cinemachine. It will give us more interesting camera operation. For example, I will click install. And once it was installed, wait for some time. So okay, now it was installed. Here we can see this green toggle. We can remove it or close it. And now here in these toolbars, file, edit assets, here we have a new option, Cinemachine, and here we can create a virtual camera. Here it is, and here we have some functions. Let's try to reset it. Let's first, here we need to select, we don't need to locate it as a child towards this object. And what we need to do here, we need to choose the object we want to follow at and look at. Previously we considered that look at function, so this camera will also look at our vehicle. So I'll drag it here and it here. So now we have our camera and we can already test it. So now it will follow our car, and now we can see how our wheels are turning and so on. So let's make some adjustments here. So what we can do here, for example, we can provide some offsets here. For example, okay, 3 is good. This one. And also we can adjust field of view. Not this one, but field of view. How close it will be to our vehicle. And here we can add some more smooth movements. For example, look ahead smooth. I'll try to increase it. So we currently edit our camera, but we can see some not clear movements of our vehicle, and that's probably because we are working inside. Here you can see some not clear movements, and that's because we are working inside the simple update function. So when you work with the physics, it's better to work inside the void fixed update, because this update function, it depends on the performance of your system performance, whether you have fast or slow computer, but fixed update will work with a constant speed, so it's better to make some physics operations here. So let's try to, example, I'll try to change our update to the fixed update, and let's see whether we will get any changes or not. And now you can see that we don't have these. Now we have really clear movements. So now, because we are working with a fixed update, so when you work with the physics, it's better to use the fixed update function instead of update. Because, for example, maybe your game is run at 30 frames per second or 60 frames per second, so it will depend, but inside the fixed update it will be always the same. So that's all I wanted to show to you today.